Today we're going to talk about the male reproductive system again, but this time we're going to focus on the external structures in that system. Okay, so what are the external structures of the male reproductive system? Well, there's going to be two major external structures. The first is the scrotum. This is the flap of skin between the legs that contains the testes, and I've highlighted or put a circle around the scrotum here. The scrotum maintains an ideal temperature for sperm survival, which is 2 to 3 degrees lower than your normal body temperature. I should say 2 to 3 degrees Celsius lower than your normal body temperature. All right. Part of the scrotum is the cremaster muscles. These control how near the testes are to the body based on external temperature. And so these muscles can contract or relax. When they're contracted, then the testes will be held closer to the body. When relaxed, the testes will hang further from the body. All right, the second major external structure of the male reproductive system is the penis. This is the structure that delivers sperm into the female reproductive tract. And the penis is composed of these parts. There's the shaft, which I've put a bracket around right here. Then there's the glans penis. This would be the head or the tip of the penis. And then there's the erectile tissue. This is spongy internal tissue that fills with blood during sexual stimulation or sexual excitement. And that's what causes the erection. When this tissue absorbs all of that blood, the penis will become erect. Now, during sexual intercourse, the erect penis is inserted into the female's vagina and the semen is ejaculated. And this propels the sperm into the female reproductive tract. Now, those were the major external structures of the male reproductive system. In a previous video, we discussed how sperm travel through the male reproductive system, but I didn't say anything about how sperm develops. So I want to talk about that now. How do sperm develop? So sperm are formed in a process called spermatogenesis. So this process of sperm production begins with stem cells that are called spermatogonia. Now, diploid spermatogonia, so these are cells that have two copies of all the chromosomes. One set of chromosomes is from the father, and one set of chromosomes comes from the mother. So you put them together, now it's a diploid cell. It has two sets of chromosomes. So diploid spermatogonia divide through the process of meiosis, and meiosis creates 4 spermatids. These spermatids, they are cells, but these cells contain only 23 chromosomes in the case of humans, which is going to be half the number of chromosomes that you started with in the original diploid spermatogonia. There would have been 46 chromosomes in that original cell, but by the end of meiosis, you end up with 4 cells that have only half that number, 23 chromosomes. No, 23 chromosomes. All right, so in a final process called spermiogenesis, the spermatids, those were the 4 cells that you produced in meiosis. So in the final process called spermiogenesis, the spermatids take the final shape of mature sperm. So that is the process that happens in order for males to generate sperm. The whole process is called spermatogenesis. You start with diploid spermatogonia, you do meiosis, and you make 4 spermatids, and then through spermiogenesis, you turn the spermatids into their final mature form called sperm. All right, so this image shows you a picture of what I just described. So as the sperm develop, they're going to migrate to the lumen of the seminiferous tubule, where they will eventually get released. So before I change slides, let me say something about this picture here. So you have, whenever you see 2N, that's a diploid cell. So you have a diploid cell, and mitosis is where you just make more diploid cells. But one of these cells can go through meiosis, in which case you end up with 4 cells that have half the number of chromosomes. So these would be your spermatids. And through spermiogenesis, those spermatids end up taking the form of the mature sperm. And like I said a moment ago, these sperm are going to migrate closer to the lumen, and they eventually end up getting released. Okay, so let me say something about the structure of sperm cells. So sperm cells have 3 main sections. There's a head, and then a midpiece, and a tail. The head contains the nucleus. That's what you see in purple here. And the and it has an acrosome on the front portion. That's the tip here, which contains enzymes to break into the female's egg during fertilization. The midpiece is surrounded by mitochondria, giving the sperm ample energy to swim. So the mitochondria is where is the part of the cell where energy in the form of ATP gets made. So there's a whole lot of mitochondria in the midpiece, and that's what gives the sperm cell the energy to swim. Okay, and then the tail, it's also called a flagellum. It spins around kind of like a little motor on a boat, and it provides movement. So as that tail whips around, that's what makes the sperm swim. All right, so to sum up, sperm are produced through spermatogenesis, in which one spermatogonium divides to create 4 spermatids, and these spermatids eventually develop into sperm. There's also 2 major external structures of the male reproductive system. There's the scrotum that keeps the sperm at the ideal temperature, while the other external structure, the penis, delivers the sperm into the female reproductive tract.